Today we're going to talk about optimizing ASP.NET websites. And we're going to look at a lot of cool stuff, and I'm going to do my very best not to waste any of your time. And we're going to have some fun. My name is Mads Christensen. I'm a program manager on the ASP.NET and Visual Studio team over in Redmond. And I'm going to take you through a real website. We're actually going to take some real code that runs today and optimize it using all the cool stuff in ASP.NET and especially in the tooling. Because a lot of what we're going to look at today is actually around tooling. There's been a lot of innovation and a lot of new features being added, a lot of new extensions. And they actually make optimizing websites pretty easy. So we're going to go through some of that stuff. But before we start, you might wonder, like, why does website optimization even make sense, right? Why is it important? Everyone's got like a very, very high-speed internet connection, like even on their phones, right? 4G, LTE, and what is all called. And that's true, but it's not always true. It's not always true. You go somewhere sometimes and you get a slower connection. And it's really, really annoying. And if you're anything like me, you visit a website, maybe a website that wants to sell me something, and if it loads really slow, I'm going to go somewhere else. I'm not going to stand using my phone on a 2G network waiting for some images to download, right? So they just lost a sale. I'm not going to buy anything from that website. It could be your website. And there is actually real science behind how this stuff works. And there's some real-world experiments. Google did one a couple of years ago. They slowed down their website, the Google search page, by 500 milliseconds. That's half a second. And the results were that they got a 20% drop in traffic for half a second. Consider that for a moment. What is half a second? That's nothing. But they lost 20% in traffic. And that's how Google makes money, right? A lot of page views with a lot of ads on them. So very, very interesting. Amazon also did a similar thing. They slowed down their page 100 milliseconds. And their sales dropped 1%. For 100 milliseconds. This is like a tenth of a second. Really, really nothing when you think about it. And they dropped 1% in sales. Now that's not a lot. That, who really cares about 1%? Well, if you're Amazon, then revenue, in 2012, Amazon's revenue was $61 billion. So 1% is $1.7 million per day in lost revenue, just by slowing their page down by 100 milliseconds. So this actually really means something. Imagine being the developer who finds out how to make a performance increase 100 milliseconds. I would go ask for a raise after that, for sure. Okay, so we can do a lot of stuff. We can optimize our database, our backend, our business logic, doing caching strategies, on our servers and so on. But today, we're going to look at only the top applications here, the ASP.NET and IIS. And we're not going to look at databases. We're not going to look at anything but that. And you might think, well, that is weird. Because if you have a slow database, then that's the bottleneck, and then everything slows down on top of your slow database, right? Well, to some extent. But if we take a look at what a request of a browser actually looks like to a website, then we see something like this. I'm sure you've seen it before. The first bar at the top represents the HTML page itself. This is where you want to display some user data, maybe some charts, whatever it is you display on your page. And that data comes from your database. But as we can see, the browser actually makes a lot more requests than just the top one. It has to request all your style sheets, all your images, all your JavaScript files. And at some point way later than when the page actually loaded is when we get the actual page load event. That's the green line. It happens in the front-end code, not in the database, not anywhere else. So it's only like a little fraction of the entire load time of a website that actually has anything to do with your database or your business logic layer and so on. The rest is all front-end. So we can optimize our database, but we're only going to we're only going to reduce the topmost bar on this network chart here. The rest is going to remain the same, so the site is not really going to be that much more optimized. So this is the top 50,000 websites in the world, and we can see that they actually have almost all their resources are all located in the front end, 87%. So yeah, we could concentrate on the back end and concentrate on the 13% of the time that it takes to load your page, but then we can only optimize within those 13%. It would be kind of cool if we can just go for the big chunk. How can we get the 87% optimized as much as possible? And that's what we're going to look at today. So, ASP.NET 4 and 4.5, if you have installed ASP.NET 4.5, you automatically get a 30% boost in startup time of your app, and you also get 30% less memory usage. All you need to do is have ASP.NET 4.5 installed. You can still run your app in 4.0 because of the way that 4.5 kind of upgrades 4.0. So you can still target your current 4.0 application and you get 30% boost out of the box. I just want to mention it because I think it's kind of cool. It's one of those things we get for free. So let's take a look at a real website here. So this is the webdevchecklist.com. It's pretty new. It's from January. Basically what this is, if you ever want to build a website, this is a super good resource to figure out all the things you need to do. Like optimizing your images, but also like you need to do some certain things for mobile, and there's a lot of online validation that you can do. You can run some HTML5 compatibility checks and so on. So it's a really useful resource. And there's links here for all the solutions to all these problems that is listed. This website also has an ASP.NET performance section. So this is the actual running website on webdevchecklist.com. And it was a side project that I built with some of my coworkers. And I think we should see if we can optimize this website a little bit. So of course the real one online is optimized. But I have de-optimized it. Right? This is how it looked like before we started optimizing anything. That's what we're going to look at. And I have the code right here. This is the website in Visual Studio. So it's pretty simple. I have some CSS files. I have a few images. A few scripts. And then the rest is just HTML, basically. So that's the website. Now, let's just run this guy. Close this one. So here it is. This is the site. We're going to use a few tools here. So this actually, wrong button. So this actually does run on my local host, as you can see here. And let's use a few tools. PageSpeed by Google and Wiselow by Yahoo are fantastic tools that we can use to figure out like what is the state of our website in terms of performance. And I assume that a lot of you already know about these tools. But there's probably also stuff about them that you don't know. I'm going to use Firefox here. So they have plugins for Firefox and for Chrome, and they also have standalone JavaScript-based versions of these plugins. But here I'm just going to use Firefox. So this is Wiselow. I can run the test, and we can see here how great or how bad our site is performing. So Wiselow tells us here that we get a grade of C. So think about the American school grading system. A is the best, right? So C could, you're still passing. You still pass the test, but it's not an A. And the number that we get here is 79 out of 100. So It could be much worse. Most websites out there are, in fact, much worse. But it's still not great. And some of the things that it complains about is that we have too many HTTP requests, we don't compress our stuff with gzip, and we don't minify all our JavaScript and CSS files and so on. So a 79 out of 100, that's why slow. Now let's take a look at page speed. This is from Google. So they're a little bit more brutal. They only give us 45 out of 100. And they say some of the same things. So these two tools, they overlap, but they're also looking at different things at the same time. So we kind of need them both. But we only have 45 out of 100. So here's a lot of things that are problematic. We don't minify CSS. We don't optimize our images and so on. So Google is a little bit more brutal here. Now the goal, of course, is to get a score of 100 in both of these tools. How many people in here have used one or more of these tools? Hands up. Okay, that's a good portion of you. How many people have had a production website reach the score of 100 in both tools? 0. Okay. It is totally doable, and we're going to do that today. So first of all, let's look at some of the components that we have on our site. So we could look here. This is the network stack. So we got the page, then we got a lot of CSS, then we have a few JavaScript files, and then we have some background images. 11 requests is what we have. That's not entirely true, because if we look at Wieslow, it tells us that we have 12, because it counts the fav icon right here. So this is sort of the state. And if we just take a quick snapshot of that. This. We can always come back and compare later. All right. So this is what we have. We have 12 requests, and we have 107 kilobytes. And this site, this website is so simple, right? There's two images. There's not a whole lot of things that we can do, yet we get a really bad score anyway. So imagine what this could be in one of your sites where you maybe have a lot of things going on. The reason why I want to use this site is because it's so simple that we can kind of easily understand the concepts. And the concepts are exactly the same for optimizing this website as it will be for optimizing any of yours. In that, there is no difference. So one thing I could do is that I could go to a specific one here, subcategory called ASP.NET Performance. And basically what we could do is that we could just go through each and every one of these items, and whenever we're done with one of them, we can just check them off. So simple, like this. See the progress bar at the bottom? We can kind of follow along, see how well we're doing. So that's a really, really good resource when you want to do this at home or at work. Simply just go through this list. We're also going to go through the list. We're not going to follow it like one item at a time. We're going to revisit it every now and again. So let's just go back to this page. Okay. And by the way, feel free to ask me questions as we go along. I know that there's an Ask the Experts thing just after this, so I'm trying to end this just a little bit earlier, like a couple of minutes. But I'll hang around later on as well if you need that. But please raise your hand if you have any question as we go along. So we're going to start with the easy stuff. And it just so happens to be that the easiest optimization tricks that we can do also have the biggest impact. So you see we have in Wieslow, we get an F, the grade of F for not gzipping our stuff. All our text-based files. We're not gzipping any of it. So we get an F. F means really bad. Like, it's the worst. So let's go into this app, open the web config. And if I just zoom in here a little bit. System web server. This is IIS. Let's get rid of this one. System.webserver means IIS. Right? We're actually talking directly to IIS before we even hit our ASP.NET website. So we can do some pretty funny stuff in here. One of them being enable URL compression. This is a very, very strange name. We're not compressing the URL. It's not like the URL gets shorter. Basically what it is that we're zipping up all our text-based files. And I do that by setting these two attributes to true. Do dynamic compression and do static compression. Dynamic compression means all your server-side code. That means all your ASPX files or Razor views, everything that happens like dynamically on the server. And all the static compression means all your static files, the ones that are served through the static file handler. So that means JavaScript and CSS, for instance. That's all I'm going to do. I'm saving the document. If we go back and do Control F5, we can run this test again. And you can see Wieslow really appreciated that. We now get a score of B. Right? So now we're up to 84 out of 100. That's better than 79. So we're moving in the right direction here. And if we look at the stats, we can also see right here, instead of 107 kilobytes, we're now down to 69. So this is actually a very, very big difference, just by changing the web config just a little bit. So we still have the same amount of requests. It's the same files that go over the web, to your browser. But now the payload is smaller. That's all we just did. I'm pretty sure that page speed is going to like that as well. So 71. Yes, sorry, question. Excuse me, can you say it again a little louder? What? Yes, I got the question. All right, that's a good one. The question was, why is that URL compression thing not in the default web config file, or the machine config, or the application host config that is on the server? And the answer is, it already is. So I was cheating, because here's what actually happens. If I remove this line, it's the exact same result. By default, IIS will compress your files. But that only happened in IIS 7.5. So if you're running your server on Windows Server 2008, you have to add this line yourself. For some reason I don't know, they did not include that in Windows Server 2008. But if you're running on Windows 7, or you're running on Windows 8, or you're running on Windows Server 2008 R2, then you're good. Then this is handled for you. Except for this little attribute over here. We can talk about that later. There's a lot of problems with this one, and it is always set to false by IIS, even the newest version. So yeah, good question. I cheated. I just want to make sure that you understand that the gzipping actually has a huge impact. Okay. So we're looking pretty good right now. We optimized our site. We removed a lot of kilobytes from the response. And if we just stay with Wieslow here, we can see that now we have some problems with a few other things. First of all, did I remove that? I did not. Okay, all right. So it talks about we have too many requests. We have too many HTTP requests. I have 6 external style sheets. Now this is becoming more and more important as more of our code actually moves into the browser. Right? Actually, our server side, if you look generally, the trend is going less on the server side, more on the client. That also means more JavaScript, more CSS. So having 6 CSS files is nothing. But they still have to be requested one by the browser down to your server in order to display the page. And that's slow. And that takes up all the available connections that the browser can actually use to ask for files from the server. Only 6 connections can be opened to the same domain from a browser at the same time. So by having just 6 CSS files, that means we're now blocking the download of any other images or JavaScript files as well. So we want to minimize that as much as possible. So we have some really, really good runtime tools called System Web Optimization. This was released a little while back. It's a NuGet package. But it basically allows you at runtime to bundle multiple different CSS files or JavaScript files into one single file. And it all happens at runtime. I'm sure that a lot of you have seen that or use some other techniques that are similar. There's a lot of open source projects out there that kind of does some of the similar things. So I want to show you a different way of doing the same thing. Now there's like 3 different ways you can bundle all your files. One is at runtime. One is at build time, like you do an MS Build task, for instance. And the third is at design time. And we've not really done any design time work at all in this area until very recently. So I'm going to use an extension that's completely free called Web Essentials. How many people here know Web Essentials? Okay. So you might have seen this. Here are my CSS files. I now want to take all my CSS and just turn them into a single file. So I can just select the ones I want, and I can say, create CSS bundle file. It's going to ask for a name, bundle1, sure. Let's keep that name. And now what we get is a bundle file. So we still have all our files. They're still exactly the same files, but now we have this additional bundle file. And that's the one that's open over here. So it's important that I kind of keep the same order. So I'm going to take my normalize CSS. Normalize is sort of the same as reset CSS. You've probably heard of that. Normalize does some of the same things, so we always want to make sure that that goes on top. So this actually determines the order of which to bundle the individual files into that single file. And if we take a look, we can see that we now have a bundle.css. We even have a minified file. And every time I change one of the files, this bundle file will be updated automatically. Visual Studio does that for me. I don't have to think about that. So if we go to my index page, which is the only page we actually have on this page here, or this website, we can see that I have all the... Oh, let's go here. Just beef up the font a little bit. So now I can actually take all of this stuff and just say bundle1.css. So I can remove everything and add this new URL. So if we look at the stats, we can see we're now down to 7 requests. And we now only have like this little one thing. Right? So this is what we did. So from 12 to 7 requests. And there was a little bit of overhead with the different files because every file has they come with their own HTTP headers and so on. So there is a little bit additional tax to pay for each HTTP request and response. So we actually lost a little bit of weight here, almost a kilobyte of weight. And that's all very nice. So of course we want these numbers to be as low as possible. The 7 and the 68 kilobytes, we want them as low as possible at any given time. So now we can actually go in and say 90. It's starting to look really good. And the score turned to an A. It's green, right? So now we got 90. So we're getting really, really close. But we need to hit 100. Now this is the 80-20 rule, right? But in this case, it's the last 10% is going to take up, well, 90% of the time. And PageSpeed is probably going to be pretty happy as well. 76, they're still not entirely happy with us here. We still need to do some more work. So let's do that. One of them is use the min file, right? So I'm going to add the min file. I didn't do that before. We want to use the minified file, which looks like this, whereas the original bundle file looks like this. So this is the one we want to use. So we're doing that right here. And if we take a look at our scripts, Modernizer is a library, it's a NuGet package that I'm using. And Modernizer is already minified. It's already just like one long line. But this one down here is not. So scripts.js looks something like this. Okay. So we need to minify this. We need to strip out all white space. We need to rename all variables to be like A, B, C, and so on. So we really can minify and get rid of all the fat that's unnecessary for my script to work. So again, we could do this in different ways. We could do it at build time. We could do it at runtime. But we can also now do it at design time. So I'm just going to right-click, and I'm going to say create a minified JavaScript file right here. So clicking that. We can now see we get a min file. Actually, I'm going to delete this map. We can talk about it later perhaps, but just for the sake of the argument. Now I have a min file. Now I'm using the website project, so this file does not nest under the other one. You see here, these kind of nest under the parent up here. For scripts, they don't do that yet. So we're actually working on make that work in website projects. So, but if you're using MVC, for instance, you're using what we're calling a web application project. This will just nest in and be really nice. So that means that now we can actually say .min. And I can save that. So now we go back to our browser, do a refresh. We can see here that we should have a pretty good grade in Minify, JavaScript, and CSS. And in fact, we do. We get an A. So that's pretty good. So for some reason that gzipping is not happening. It's probably a bad day for IIS Express. So I'm just going to restart it basically. Go. Okay. What the? Okay, come on, IIS Express. Oh, here we go. Here we go. There we go. So, all right. So far so good. Now, here's a very, very tricky thing that we need to do. Both Wieslow and page speed tells us that we don't leverage browser caching. So it's complaining about some CSS files, JavaScript files, and the image files. It complains that we're not using the browser cache. This is always very, very difficult because of the way browser caching work. For the scenarios I have here, it's a little bit easier because we're not dealing with user data and so on. But basically what we want to make sure is that we tell the browser that for all my static resources, the browser should cache them for at least a year, 20 years, as long as possible. The actual specification, HTTP specification says, well, you can maximum do it 1 year. So let's just do 1 year. We want to make sure that if the browser has visited the website once before, it should never download any images or style sheets unless they have changed. I think that makes sense to most people. If the site hasn't changed, don't download all the resources. Just serve it from memory, from your phone, your desktop, whatnot. So this has also gotten really, really easy over the years because we can now, again, go into our web config. And we can start playing around with static content here. Whoop. So here we go. So now we can kind of control the cache. We can say you should use maxage. Any static file should have a maxage HTTP header with the value of, in this case, 365 days, 1 year. So what we now can tell the browser is that any static resource served from the site, CSS, JavaScript, and images, should have an expiration in the browser's cache for 1 year. So we're doing a little trick here as well. We're actually remapping the file extension of JavaScript files to be served as text/JavaScript instead of the default in IIS, which is application/x JavaScript. So we're going to change that because then we can trick the IIS into serving JavaScript with treated as static files, and therefore this whole MaxH will also apply to static files. I don't know why IIS did this, but sometimes we have to do some tricks to get everything the way we want. So this is pretty nice. If we go back, you see this is pretty easy, right? Just web config. Nothing happened. I might have to clear the cache here. What? It's as though it does not even run my system web server. Oh, I haven't saved it. Thank you. That would explain it. Oh, yeah. So now it starts to look really, really good. 97 out of 100. All right? We're getting really, really close now. And basically all we did was that we took all our static files, so for instance these two JavaScript files, and we added a expiration. So here, oh, it's on the MaxH, so we can't see it here. We need to go here. So let's look at the min file. And do this. So we can now see here that we have, on our JavaScript file, we have a MaxH. So this is a sliding MaxH, always telling the browser, just don't even consider downloading me. And what that looks like, if we look again here, it looks really, really good. So the chart over here on, what is that, your left, is if the browser has never visited our page before. And the chart on the right is if it already has been to the page at least once before. So you can see here we're actually doing very, very well in that when the first time the browser has to download 7 files and 54 kilobytes. Second time the browser visits, it's only 2 requests and 6.7 kilobytes. So we're really trying here to optimize for what is called the prime cache scenario, like the second visit or the re-entry scenario. That looks really, really good. So we're getting closer. Okay. Question? Yes. I know where you're going with this, and luckily that was actually my next demo. So the question is this. Well, if the browser caches my JavaScript for a year, and I make a change in one of my JavaScript files, then the user's never going to see it unless they wait a year. That is absolutely true. And the setup I have right here is absolutely true. This is useless right now, right? Because I probably want to make a change to my website at some point. So we need to do something that is called cache busting. We need to kind of trick the browser into download our new version of our JavaScript, even though it has cached it for a year. There's only one way that can be done. And so let's take a look at that. So let's go back here. Let's find our here we go. So there's only one way we can do that, and that is if we change the URL of our JavaScript and CSS files or images to be to change every time the document changes, every time the JavaScript changes. So in this case, we want to make sure that our CSS file is being updated, and I have a little helper method for this. If you use the system web optimization runtime component that we have in NuGet, then you're already covered. It takes care of it for you. But I'm going to show you how you can do this stuff yourself. If you use some other types of file system virtual path providers and whatnot, you might actually have an interest in rolling your own version. So I'm going to show you how that is done. First of all, I'm just going to call the method so you can see here how it works. So I'm going to fingerprint, that's what I call it, fingerprint.tag, and I'm going to pass it in my string here. Hit save. So I obviously wrote a little helper called fingerprint. So if we go there, here's what's going on. This is all the code there is. So what are we doing? Okay. We're finding the root relative path. We're finding that on disk, the actual physical location of it. Then we're figuring out when was it last written. And then we're going to get the ticks out of that date, the date of which it was last written to. And then we're going to insert those ticks with a little V dash into the path of that reference. And just, so we're doing performance, so we want to make sure that we only do it once. We use the HTTP runtime cache, right? So we look at the file on disk, when was it the last write time? And then based on that, we construct a new URL. So let's actually look at that. Let's see if I saved everything. Yes. So you can see we have this weird string here. So I actually injected inside my path to the CSS file this folder called v dash and then the datetime ticks. Obviously, this folder does not exist, so something more must be going on here, and there is. A thing that most people don't really use, and maybe are not aware of, is that we can do some pretty funky stuff in the web config with URL rewrites. So URL rewrites let us kind of take the request pipeline before it even hits the ASP.NET engine, when it's still just out in the IIS. And we can interact with it. And that's very, very simple. We do that right here. And here I have a rule in my rewrite section called fingerprint. So basically what I'm doing is I'm looking for a pattern that says V dash and then a number. And then I'm rewriting it where I basically just remove that V dash something. I just remove that out of the path. And that path is what's being sent by the IIS down into ASP.NET. So my app does not know anything. Does not know that this URL rewrite just happened. It doesn't know that what the original URL was. Well, I can ask for it, right? But I don't have to change my app. I can do everything here in URL rewrites. And that's why it still works. That's why you still see, when I do a F5, you still see that we have styling on the page. So it didn't really do anything to our statistics here. Right? We still have the same amount. We still have 7 and 2 requests. We still have 54 and 6.8 kilobytes. Those are still our numbers. The only thing that we did here was for us to use the expiration of a year, we have to do the fingerprinting or the cache busting. It is very, very crucial that those things go together. Does that answer your question? All right. So that also means that we're on the same score, 97 in page speed. Oh, sorry, in YSlow. And 98 in Google PageSpeed. But that's not good enough. It is not good enough. So PageSpeed says, hey, you should optimize your images, and you should minimize or minify your HTML. All right, those are the 2 rules that are right here. And YSlow tells us to configure our E tags. Okay. What should we do first? Let's optimize our images. So normally when you optimize images, what do? Maybe you get some images from your designer, or steal them online, or whatever it is you do. And how do you know if they're not optimized? Well, maybe you don't. That's fine. But then how do you figure it out? Well, you could use these tools, and they will tell you if they're not optimized. The real problem is, how do you then optimize it when you figure out that you need to? You could open Photoshop. Like if you have 2 gigs of memory that you don't know what to use for, then open Photoshop. And you can save as for web and optimize it through there. That's all good. Paint.net, they all have these abilities to optimize images. But as it turns out, they're not very good. Stuff like ImageMagick, PNG Gauntlet, and other smaller executables are actually way better. But what we really want is when we take all these different types of open source projects, most of them are, we want to run them all on the same images. So we want to take multiple different approaches to optimizing our images for each image that we have. That takes a long time. That's not very useful. So it would be really useful if we could just use some of these services that does this for us. One of them is Yahoo. They have a service called smushit.com. There's another one called punypng.com. And what they do is that they run, you upload your image, your PNG for instance, and they will run ImageMagick, PNG Gauntlet, and all these different tools, and they will losslessly optimize your images. So there will be no change in quality, but we can actually remove a lot of unneeded bits and bytes. So they actually rearrange the color palettes, they remove all EXIF data, all this sort of stuff. And yeah, that's true. We can go to these smushit.com, but what we can do as well is just to go into Visual Studio, find our images. We only have 2 images. It's basically fork and menu. So these 2 guys. And I can now right-click them, and I can say, optimize image. There we go. And we can see what the result is in the output window. So even though these are small images, one of them we could reduce by 53%, and the other one by 17%, just by a right-click. There is going to be no one can see the difference. There's not compromising of quality in any of this stuff. It's all just rearranging the bits and bytes in the image. And you can see it does in fact use smushit.com behind the scenes. If we had an entire folder of images, I could just have right-clicked the folder and say, optimize images. So this makes it a lot easier to do this stuff. And if we go back, I probably need to clear the cache for this one. And we refresh, then Google says, no, unfortunately, I can optimize one of your images even more. So this is always the problem. So all these different services, they all run different sort of tools. Sometimes Smushit is better than punypng. Sometimes punypng is better than Google, and vice versa all the way around. So in this case, we were actually better, the smushit.com was better than Google for one of the images, but for the other one, not so much. But then this tool just says, hey, you can save an additional 24%, and I can just say save as. So I'm just going to say save as. Which one was this? This was the fork. So this guy. I'm going to say yes. That's it. So I just saved it in my project path, and I'm going to do a refresh. And it no longer tells me that I have a problem with my images. We only have minification of HTML left, and our score is now 99. So we're getting there. So Wieslow is still pretty solid on 98. That's all good. And everything here is the same. But it says something about minifying HTML. Now this is problematic. Has anyone in here ever tried to minify HTML? No. One guy. Oh, is that a question? Okay.
What about dynamic images like avatars for users? Can you minify them on server side?
What about dynamically created images like profile pictures of users that are served through maybe an HTTP handler or something like that? was the question, I think. Yes, you can do exactly the same thing. At some point in time, the user is going to upload his image, right? And you might crop it or whatever. The user maybe crop it. So the DLL that's actually running in Visual Studio is open source. It's on Codeplex. And so you can just use that, and you can include that in your own website. And so you can call it, it's just an API. You just basically call it and say, hey, crush this image. I think it's called Image Crusher, that Codeplex project. So everyone can just use this. And the call to the Smushit service is free. Okay. So minify HTML. We still have that left. Configure entity tags. So let's take a look at the web config. So, question. Where is it? Was there a question? No? Oh. Yeah, so the question is, what about resizing images? Can you do that through a NuGet package or within Visual Studio or whatnot? Oh yeah, okay. How did I get that menu item? I right-clicked an image, and I actually have two. We're going to talk about the second one later, but I actually have one here called Optimize Images. It is in a free extension called Image Optimizer. I'm going to show you the links afterwards. But I'm using two extensions here. I'm using Web Essentials, I'm using Image Optimizer. Web Essentials only works in 2012. Well, there is a version for 2010, but it doesn't have all the same cool features. Whereas the Image Optimizer works completely the same way in both 2012 and Studio 2010. If you want to do resizing, there are NuGet packages, which, there are some good ones out there. We don't provide anything from the ASP.NET team. Okay. So if we look at our checklist here, we did a lot of stuff. We compressed all our text-based files. Well, we didn't really run in release mode or disable tracking. So let's do that. I know you all know that this is something you have to do, but let's do the checklist here. There is a reason for why these items are there. They are going to slow your site down. So now we're running in release mode, and I disabled tracing. And again, I was cheating. So back to the same question. What if I don't have this line? Well, then you already have tracing disabled. Right? So I'm cheating to make a point here. Remember, if you have it, remember to set it to false in production. We bundle our style sheets. We only have one JavaScript file. Well, we do have two JavaScript files, don't we? So what I could do was I could go in here and I could take these two files and bundle them into one, just as we did with CSS. I don't want to do that in this case for a very simple reason. And that is that Modernizer has to be in the top. So for those of you who do not know what Modernizer is, it's basically a library that kind of fills in the gaps between old browser and new browsers. So if you're using HTML5, for instance, some new tags like section, header, footer, and IE7 comes along, then IE7 does not know what's going on and it cannot render your page. Modernizer helps with that. If you just, as I do here, just have a reference to Modernizer, it will fix all those things. And it has to be at the top before the actual body is loaded. But my second script right here should actually be where all scripts should always be, at the bottom. Modernizer is the one exception. You always want to put scripts at the bottom of your page. So for this guy, we should remember to do our fingerprinting. So fingerprint.tag, put it at the bottom, and here we go. So that's very, very easy or very important to remember. Script tags actually block rendering. So if you have 2, 3 tags, script references on top of your page, the browser will stop downloading the rest of your page or any other style sheets or images that follows where those script tags are located. So adding a script tag or script reference is a blocking thing to do. And you never want to do that unless you do stuff like document.write, which you probably are not going to do or not doing very much. Or if you're doing, stop doing it. You always want to move it down. In case you cannot do that because you use some CMS, you use a CMS system or whatever, so you only control certain aspects of the app and you have to inject your JavaScript somewhere in the head, for instance. Then what can we do? Well, we can actually do some stuff. We can do defer. And if you're like me, you like the actual attribute value to be there as well. Defer equals defer. So basically what it means is that, hey, don't download this JavaScript file, but don't execute it. Just wait till the page is loaded, it's fine. So that's really nice. So that means if we have the script tag in the header, then we can actually just continue parsing the document because we're not synchronously executing the JavaScript. But we want to do even more, so we can say async equals async. And this is the holy grail. This is the one that completely removes our JavaScript from blocking anything or doing any paint events or all these things that a browser has to do to display your page. Right? The only problem with doing this is that if you have any objects in your JavaScript that other JavaScript files rely on to be there in the DOM, then you might run into some race conditions. So you can only do this if everything runs on page load. Like if you use jQuery, you can use the jQuery constructor to say only run when page is loaded. Then you're fine. But just be aware of it. You have to try it out on your own site. My guess is that probably 90% of your script files will work just fine with this. So async is good. It's really, really good. But that's why I don't want to bundle them, because I need my modernizer script to be up here in the top. So that is why. So let's just say, yeah, I'm going to strike this one because I'm going to pretend that I don't need it, which I don't in my case, so it's perfectly fine. We minified JavaScript, we minified style sheets. What about HTML? This is the crazy thing. Minifying HTML, which means remove all white space. Remove all unneeded characters from HTML that is not needed for the browser to render a page correctly. Problem here is you can't really do that in a very efficient way. You can use regular expressions, but regular expressions cannot parse HTML. It is physically impossible for regular expressions to do that. And even if it could, it would still be a huge amount of work. So this is something that I've been doing for many, many years, but I've always done it a little bit differently for each project that I do, because the solution that worked for one project does not necessarily work for the next. So I'm going to show you one that's really, really brutal. I have an HTTP module called whitespace module right here. And basically what it does is that it adds a little filter to my response. So here it is. So basically, oh, stupid mouse. So basically, I'm looking at which request that I'm interested in. And in this case, I'm interested in CSHTML. And if my request actually sends a CSHTML, or it could be ASPX or HTML for that matter, then add this whitespace filter, which I have right here. And it does a lot of things. Most of it is boilerplate. Now, this is the interesting part. Basically, what I do is that I read the response string. So the actual string representation of the HTML going from the server to the client is what I'm reading right here and putting it into my string variable. And then I'm going to regex, run 2 regexes on the HTML itself, and then I'm going to write the result back. So I just told you, you can't use regex to parse HTML. And that's not what I'm doing here either. I'm actually not understanding HTML. I'm doing something very, very dangerous. I'm removing all white space, all line breaks, all unnecessary multiple space characters, and so on. So let's remember to save, and let's take a look at what that is. So if we look at it right now, I didn't hit F5. This is what it looks like just without it. And if I hit F5, oh, this is what it looks like now. So basically, one line, okay? So obviously this is more optimized in terms of white space than it was before. But it is also one line. And what happens if I have a text area element or an element called pre? Those two elements are white space aware. So if you were using a text area, let's say you have a contact form and you let people type in stuff or something like that, comments on your blog, then this will completely fail. This is the most brutal version of the white space module that I have ever used. But this website is so simple that it doesn't really matter. I don't have anything that can break using it. But if you used it on your sites, 99% sure that it will break something. So keep that in mind. I have a blog series. If you go to matschristensen.net, I have a lot of blog posts in there for removing white space safely. Like how do you do the version that doesn't really do that much, but it still removes enough for it to make a difference. So I'm being really brutal here. It's one line. So let's try page speed again. So now we actually made it 100 out of 100. That's pretty nice. And 98 in Wieslow. Oh, it has an issue with my fav icon. So we should try something with the fav icon. Sometimes this works, sometimes it doesn't. I haven't really figured out when or why yet. So let's try that. We're going to remap the ICO file. Oh. So I'm going to take my ICO and I'm going to remap it to image x-icon. Save this guy. Go back here. We can run it again. It didn't bite. It didn't bite. Could be caching. Fav icons are a little bit strange. Okay. So we worked our way down the list. We use long expiration. We fingerprint our resources. We don't actually use conditional gets. We can go back to that if it's important. We optimize our images. What is this now? Inline small images, it says. This is pretty crazy stuff. So I was optimizing my images, that's fine. But I can do two things beyond just optimizing images. I can use image sprites. That means make one big image that just contains all the small images. And then use CSS to use background positioning to move that big image around so only the visible single image appears for the user. So that's pretty tough to do, and it's always application specific. It's really difficult to do, but we can do something that's even cooler than that. We can read the image bytes from the disk and inject them directly into our HTML or CSS. So in this case, I'm using CSS for my images. They're basically just background images. And I have one right here. This is my menu. So if you hover it, it looks like this. And what I can do, as I told you, I can make what's called a data URI. Reading the bytes of the image on disk, base 64 encoded so it becomes a string, and then just add it directly to my style sheet. Now that sounds very, very complicated. And it is. It is really, really complicated. Unless, of course, you have Web Essentials. So in Web Essentials, I can now use this smart tag on the URL. And it has a button saying embed as base 64 data URI. Let me click that. So what just happened? Well, first of all, we have a data URI. You see, this image is really, really small. So it's a short string. It also added an additional line right here that is exactly the same as the one I had before, but it has a star in front of it. And that's because that this guy right here, the data URI is not supported in IE7 and IE6. It's fully supported in IE8. So what this tool did for us is that it now registers the exact same property with the old reference to the image that's only visible to IE6 and 7. This is an IE hack. And sometimes we have to do this in the real world. We have to kind of do hacks to make everything work. If you don't care about IE6 and 7, you can just delete this line. But it is actually pretty cool. So when IE9 or 10 or Firefox visits our site, it will look at this property right here and say, oh, it's a background, and oh, it's a data URI right here. I understand that, so I'm going to use that. Then it moves down to this line, and it says, oh, star background? I don't know what that is, and then it ignores it. IE6 and 7 is going to do the exact opposite. So this is completely safe to do in browsers, all browsers. Here's another one. Just going to do exactly the same. Here we go. And I'm going to save them all. We can now go back, hit refresh. And if we look at our stats, we now see something interesting. We have fewer files. We have 8 files. Okay, what happened? Didn't refresh. Ah, I know why. I know exactly why. So this is because we need to build, hopefully. Yeah, so here we go. So we can now see that we no longer have any images. There's no images anymore. Okay? We have HTML, we have 2 JavaScript files, 2 style sheets files, but no images are sent over the wire. So we just removed 2 HTTP requests just by right-clicking in my CSS file. Now, see, so tooling has come a long way now. We can actually do this, and it really, really makes sense. But you might think, well, okay, so you just embedded those images, but what if I change the images themselves on disk? What if I get a new version of that image from my designer? Then do I have to do everything all over again? Well, no. Because if you already have an image like this, and you invoke the smart tag again, then it's actually clever enough to say, do you want to re-embed this one? Right? So it knows what the original image was, where it was on disk, and you can re-embed it. So you're completely safe in using this. Okay. So far so good. One thing that Wieslow tells us is that we need to make sure that our fav icons are small. So the fav icon is the guy we see up here, this little check mark, right up here. And if you're anything like me, you go to some online website like iconfinder.com or whatever to find your fav icons, or you get some from a designer. But how do you know if the fav icon is optimized? Most of these optimization tools that I was showing you before actually doesn't know what to do with a .ico file. They only work with JPEGs and PNGs and GIFs. Well, as it turns out, we already have a pretty good icon editor. I'm not talking about Paint. Here's my icon. I'm talking about Visual Studio. Even 2010, perhaps before that. I opened this ICO file, and we can kind of see what's going on here. An icon file can have more than one version of the icon. You can have one in each size. This one has 4. And if we take a look at the size of it, we can see that it is 32 kilobytes. So a 32 kilobytes icon file. And this is an icon file that all desktop browsers will download. Hanselman, he had a couple of years ago, he blogged about that he figured out that I think it was 70% of his traffic of his blog came from his favicon file. Because who thinks of optimizing your favicon? But every browser is going to download it, and his was like huge, like 100 kilobytes or something. And that's because that he had an icon that contained a lot of different icons. So I've seen some that are much bigger than this, that has like 3 times as many images in it, all the way up to like 500 by 500 pixel size. But we don't need that. So we can just go in here and we say, yeah, I don't need the 64 by 64. So I'm going to right-click and just say, delete image type. Maybe I don't need this one either. This is 48 by 48. And maybe I don't need 32. So this depends on what you need, right? So I'm just saying I only want the 16 by 16. And I just saved. And if we go back and look at it now, we can see that we're actually down to something more manageable, 2 kilobytes, probably less than that. Yeah, here we go. So not even a kilobyte. I took the wrong one, didn't I? There we go. Yeah, 1.12 kilobytes. So that's a huge difference from going from 32, right, and then down to 1. So let's rerun this guy. And we can see that it now looks really, really, really good. So for page speed, we're good. We're all good. For YSlow, it probably still gives us grief about our favicon. See here. It does. We only get 98 because our expiration for the favicon is not set. I'm starting to believe this is an IIS Express thing because it totally works on IIS. And that will give us 100. So if we take a look at where we were before we started, you see that we actually come a long way. Right? So we went from 12 requests down to 6. We went from 107 kilobytes down to 22. Nothing changed. No behavior changed. Most of it was just web config and tooling tricks. It was very little that I actually had to write in my app. Like 3-4 years ago, I've been doing this talk for like 6 years. It was like a level 4 or 500 talk that went on for 2 hours. That's not the case anymore. ASP.NET website optimization has never, ever been easier. And if you know the right tricks in the web config, if you have the right tooling extensions, then you've come a long way and you can get all this done very, very quickly. But the really interesting thing here is how the prime cache, when the user already visited the site, that it's down to only 2 single requests. That is really good. We could, however, get it down to 0 requests. There are 2 ways we can do that. One is using the new HTML5 offline cache, application cache capability. Some of you, I'm sure, is aware of what that is. That is not a good idea for a lot of reasons. It is a good idea for other reasons. Some websites, it makes perfect sense. For other websites, it does not, and it's difficult to write. But there is one other way we can do it. Now, how often do I have to do I change this website? The site itself, not the scripts, not the CSS, but how often does the content, my HTML, how often does it change? Well, for this website, it does not change very often. It might be like dynamic with like JavaScript and such, but the HTML sent over the wire is probably not going to change. So it would be kind of cool if I could do something there. So I actually use this little trick where I say, if the request is not coming from localhost, then apply HTTP caching and server-side caching to the page. But since we're, of course, using localhost, it doesn't work. So if I remove this if sentence or statement, now we're actually doing some stuff here. First of all, I'm going to say that I'm going to set the expiration date to 2 days from now, because I'm pretty sure that I'm not going to update this every 2 days. Actually, I'm probably only going to update this website every 2 months. So I think 2 days is just fine. I'm going to set it valid until it expires. That means on the server, just cache it on the server. Don't run all my partials and all that stuff. Just serve it out of the cache on the server based on how many days of the expiration, 2 days. And make it public. And then we're going to add a file dependency to the last modified. It doesn't actually have anything to do with, well, it does have something to do with the cache, but not for the stuff I'm going to show you now. So basically, the browser visits my page. And the page itself, the HTML, now tells the browser, cache me for 2 days. Next time you come in here and 2 days hasn't passed yet, just serve me up from the cache. If you were using web forms, you would just use the output caching, right? I'm not using web forms, so I don't have that luxury. Actually, it's something we're working on getting in for Razor as well. So if we now run this guy, we should hopefully see that our document here now has an expiration of 2 days, right? March 8th. Go. Oh, I need more? Let's give it 7. Probably need a little bit more. And we need to build and touch the web config. So now we're server-side caching. That is the trick now. And here we go. Right? So now we can actually see that we have completely removed any need for the browser to re-download our site. So it says that the fav icon is problematic. Run this on full IIS, and that will go away too, and we will have 0 requests. So now we actually have offline capabilities without using the whole HTML5 offline manifest cache, whatever it's called, just by setting expiration. Right? So I guess that's it. This is now super optimized in 1 hour. So if you don't have any questions, and as I told you, I'm going to stay here. I'm going to stay out of the Ask the Experts as well. So feel free to come up, or I'll meet you out there. But if you don't have any questions, then thank you very much for showing up.